Okay, we're continuing on with the standard project here. It's been some time since the last videos that you saw since I've gotten back on this project. Just time, life happens, stuff gets in the way. Other projects got pushed in front of it, and I've been thinking about this the whole time. I don't like the way this crankshaft looks. It's rough and pitted, and it's going to have some pretty serious attention. So here in the last couple of weeks, I've been trying to figure out how I can machine this surface. I'll show it to you. The throw here for the rod is just as rough as a cob, and it's terrible. It'll run. It would run, but I don't think it'd hold a bearing very long. And I want it to be able to run indefinitely. I don't want to have to worry too much about it. This doesn't get a lot of oil anyway. You'll see that when we put this back together. It's a wonder this is in as good a shape as it's in. It's worn pretty badly in the center, aside from the pitting. So I can tell it's been starved with oil. I'm going to put an oil light bushing in the rod too that will carry some of its own oil. And this isn't a real high-speed engine anyway, so I think it'll work. But the problem at hand is resurfacing this crank throw, and I'm also wanting to resurface the mains here too. There's a lot of pitting here. This pitting here doesn't make a whole lot of difference. The bearings run out here and out here, so wherever the bearings run, I'm concerned and want to put a low friction surface on them too. So what I've come up with, I'll show you here, and I've made some fixturing and been thinking about this for a long time, kind of dreading it really, but it's time to get on with the program here. So let me show you what I've come up with here. All right, over here I've just flattened in the mill to make true, just a piece of flat stock here, drill a hole in it. And what I've got is, there's a dot of dirt there. It's probably messing up your view there. But anyway, this is lathe center right here. Let me get a pointer. This is actually lathe center. This crankshaft has a 1-inch offset for a 2-inch throw. So 1 inch from here to here. And when I set this up, I will use this to help get me in the center of the lathe. And here's what we're going to do. This crank is going to be, I've also machined a piece here that's tapered. This taper matches this taper, so that'll go on there, and those tapers will lock together and lock that all up tight. Then this piece here goes on, and then the nut goes on it, and that'll all have to be tightened up. But anyway, the throw will be aligned with the center of the lathe, and I will chuck this up in the forejaw so that this whole thing will rotate around like this around the center of here, and this throw will turn true. Then I can get a tool in there and machine that and resurface that surface, and I'll make another bushing to fit the new diameter. And then there'll be a different setup to set it up in the lathe to machine the mains. Kind of a simple deal for a lot of people, but it's just, it takes time to make the fixturing and think about what I've got to do and present it to you guys. So hey, if you like what I'm doing, like and subscribe and stay tuned, and we'll see what we come up with here. Hopefully it'll work. So next time we come back, I'll try to show you getting this thing chucked up in the lathe. So actually, the next thing we have to do is reestablish these centers in here. Let me find my pointer. There's a center here, and then there's just a dot right here. I'm going to have to jig this up in the mill and locate these and reestablish them. Here's the live center. The live center's got to run in those little live center drillings so that it can help keep everything from shaking around and keep everything running true. So I've got to reestablish these 2 points. And to do that, I brought over the angle plate here. I'm going to end up fixing it on the angle plate, clamping it down, getting it all trued up, and then I'll put this assembly into the milling machine, and I can come down with an accurate pointer here and locate this, then put a drill in it and a center drill in and re-establish these 2 points so that all this can be machined together. The coordinates can be kept and everything can be, true. So that's the next point, next thing to try to do. And so I'll get this clamped up here. Well, here's the setup over on the mill. I've got it nestled in here pretty close to the vise. So anyway, I've just made some clamps, or clamped it on to the angle plate, and clamped the angle plate down to the table, and that gives me an opportunity to check these centers. And so I'll show you how we do that and show you how we actually will remachine that point. So basically what I do to set the center, find the center of that dot, is I stop this thing from wiggling, and then I can run it down with the quill and run my table in and out to where I can get it to set right in that little dimple. And when it sets in there and doesn't move, I gotta come over just a little bit more here. I'm moving the table just very much, just a very little bit. Now it's setting in there and not moving. So that is the actual true center of that dot right there. And we'll come back with a drill and drill that. So you may ask, what if that dot is not in the center of this throw? Well, there's a way to measure that. I'll show you how we measure and make sure we've got this area directly underneath the quill. Let me get set up for that. Well, you know, the wiggler here is a great way to find a center punch mark that you want to locate and drill exactly. But what if that center punch mark that we just looked at is not in the center of this throw here? Let's check that. So what I've got set up here is a coaxial indicator. And I've got the short finger in it here, and I've got it down here at the bottom. This is pretty egg-shaped, and you'll see that here on the dial when I fire it up here. And what you do is you just you move the cross axis, the x-axis, and the y-axis till you get a minimum indication here. It doesn't have to be 0, and it won't be 0 on this irregular surface. But when you get to the minimum, where there's the minimum indicated movement here, you are directly over the center. So let me fire it up here and I'll show you. This is a little rod here that I have to hold on to, or otherwise the whole thing will turn, which doesn't hurt anything, but just can't see the gauge. So let me fire that up here. Now I'm going to move the y-axis a little bit here, and you'll see that gauge really start to swing. I'm going to bring it back. There's the other way. It's starting to swing the other way. I'm going to push it away from me now. And there, it's going the other way. So I want to get in between that. Not right there. And what you're seeing right there is the egg-shaped of the crankshaft. Now I'm going to go left and right here. There it goes, you know. I'm going to bring it back to where I've got the minimum amount of movement there. Now you can see just there's a dip in there, probably one of those rust pits. Let me move the quill up and we'll sweep up along I'll show you just how bad this thing is. Up here at the top, there's some dents up there, but that's about as close as we're going to get that. Let's sweep it back down here to the bottom. That's just another method of being able to center your your quill, your spindle, over the point that you want in your work. So I'll get set up again for the drill here, and we'll see if we can go ahead and put a dot in that thing. Okay, so I've got the wiggler set back up here again. Let me stop it from wiggling there, and we'll set it back down in that dot and see what happens. Well, that dot was in the center, but now we know. Now we just proved it by two different methods that we are directly over the center of that crank pin. So I've got a little center drill here. I'm going to put it in there. See if it'll reach down that way. I've got my table locked. And we'll go ahead and see if we can drill that. It's kind of hard. But it's going. Show you what we got here. All right, now I've got a nice clean, well-centered, tapered hole there that will hold my center and hold me in position. Now I'm centered up over the center hole here for the mains. If I stick the wiggler down in there, it doesn't move, so I know I'm over the center of the mains there. So let's drill that one. Get set up here with the drill. Try not to hit the camera. And I'm just about pulling some rust out. Let me reset that. Yeah, we're down to clean metal. That looks great. There. We've established the center of the crankshaft, main bearings, and the center of the rod throw. Okay, I've got the fixture in the four-jaw here, and I just run that wiggler up here into that dot that I made with a center punch, and I just merely rotate the machine, and I've got an indicator against this finger sticking in there, and that gets me when this indicator runs true like it is now, not moving. I know you probably can't see it from your vantage point, but I've got it dialed in pretty well on the chuck here. So that tells me that lathe center is right on that dot. And so now I'll go ahead and bolt the crankshaft in here and set the lathe up the rest of the way, and I'll show you what we come up with here. Okay guys, here's the setup. I've made a couple of passes here, and boy, it's pretty dirty, but it's cleaning up. So boy, it egg shaped and hollowed out in the center and everything else. So let me set up here. We'll get the power feed going here. I'm taking it real easy, and Trying not to screw this up. And I think we're going to get there. So the setup seems to be working fine. I just set it up until my dot here at the end ran true, and then I run the center into it and held it there with the center. So all the center's doing is keeping the work from pushing away from the cutter at this point. Taking real light cuts, and then I'll work it down with some emery cloth, and we're going to call it good. Maybe take a real slow pass on it here for a finish pass. I'm getting up to the end here. I'm getting ready to stop it. I'm going to hand feed up to the very end. Then I'll back away. And let's take a look. It's pretty much all cleaned up except for one little divot right there. I don't know, you probably can't see it, but it's working. So I'm going to go ahead and finish this up and make another pass here and bring you back for the final results. I need to change the gearing over here in the gearbox anyway to run this travel speed a little slower, so let me do that. Okay, in quest of a better finish, I've decreased my travel speed across the work and increased the RPM just a little bit on the spindle. And it looks like I'm getting a real good cut there, so I'm going to let this traverse across and see what we end up with. But boy, so far it's looking great. Yeah, we're cleaning up pretty good there now. I'm not going to ask for too much more than this. I'll be able to get some emery cloth on it and clean it up a little bit. Surprised with the amount of stick out I've got on this bit that I'm not getting any chatter. I hear a little bit there, but boy, nothing to speak of. I'm going to sneak up here by hand, right up to the very end. Right there. I'm going to back out and back away. And let's take a look at it and see what it looks like. I'm going to call that probably real good. And I will work that down with some emery cloth. And man, that's really looking good. So, all right. I don't want to run it too fast because it'll go out of balance. Let's try to bring it up a little bit here. You got to be careful doing this. It'll grab that emery cloth, take it right out of my hand, and if I don't let loose of it quick, it'll pull my hand in here, and I don't want that. So I'll keep polishing here. Bring you back here in a little bit. And I'm polishing it both directions. I'll turn around that way. Got all the marks out of it. I just bringing it down to pretty good polish here. It's a darn sight better than it was. That will do it. And even a little bit with the back side. Just to finish cleaning her up a little bit here. Want to grab that paper. I think that's going to work. Looking good. Well, I apologize for that noise I've had on the mic here. It must be something with the DRO here on the lathe that is interfering with the receiver. I've checked. I've got another transmitter, and I heard it on it too. So I have changed position of the transmitter, and I may have to change the position of the receiver, which is up here on the camera. So let's see if that's still doing that. So yeah, bear with me for a second here while I show you this angle. And let me, looking for this noise here. Sorry to put you through this, but let me run this up here. And the lathe runs with a DRO, or not a DRO, but a VFD. This is the master switch here. This is my on-off and reverse. And this is variable speed. Very handy controls. And it's all done with a VFD down underneath here. Take a look under there. There's a little Tico under there. It converts 220 single phase to 220 three phase. So it works pretty well on this lathe, except for the noise in this mic. So I'll work on that. We'll see what we can come up with here. Sorry for the shaky camera. Okay, the noise was the VFD. Whenever I had it turned on and the lathe running, it was in there, so that's not good. Run a Rode microphone on here. They're like these little fellas, little wireless deals. I haven't had that before, I don't think. So I'm gonna have to, maybe if I just move the camera back away a little bit, but I can't get it too far away because you won't be able to see anything. But anyway, at least we got that much of the throw done. I'm gonna pull it out of there now and set it up to do the mains. So we'll keep at it here. Tell you a story that was something else here. I see this broken file. I thought, well, maybe I can get my file in there and file on that a little bit, and this counterweight come around and caught that file and snapped it off slicker than a whistle. So I learned a lesson there real quick. So I didn't get to file it any, but sure got to work it down with emery cloth, so that's okay. But anyway, let's get this apart. Oh, like I was telling you, this was going to be, this taper was going to hold it fast, and boy, it did. I'm going to have to knock it off of there. There it comes. So yeah, there we go. And I'll get set up now, and we'll use this new center here and this old center, which is in pretty good shape here, to do the rest, the mains. Okay, at the risk of getting the noise on the microphone again, I'm going to show you this real quick. This is a setup for doing the mains. Taking the finish cut here now. So it's working pretty well. Just barely taking them just a little bit off. And we're coming up with a pretty decent finish. So just wanted to show you that. When I get it out of the lathe here, we'll take a look at it. Okay, well, I didn't bore you with all the polishing and all that to finish this thing up, but here it is. The pits are all gone. I even undercut the center here, so it would hold a little oil in there maybe, and give a little space to hold oil. And also got rid of the pits, so that's fine. The only bearing surfaces are on the outer edges here. So we've got a good crank pin now, and we've got good mains, and I think everything's looking pretty good. So, you know, we're gonna give it a shot. At least this much of it's done. So I feel better about it now. Turned out pretty well. So we will continue on with another aspect of the restoration here. Thanks for watching. Well, that concludes part 3. Hope you're enjoying what I'm doing here, and we'll keep going. If you like it, leave a comment, like and subscribe and all that stuff, you know. So appreciate you watching. We'll be back in the next one.